Clouds and weather. Clouds form when water vapor rises, cools, and condenses. The result is clouds, which contain billions upon billions of water droplets or ice crystals, taking different shapes and sizes depending on where the cloud is formed. The moisture in the clouds will come back to the earth as rain or some other type of precipitation. This is all part of the water cycle. High-altitude clouds. Cirrus clouds are white, very wispy looking, and usually mean fair weather. They're completely made of ice. Cirrostratus clouds form a high, thin sheet that covers the sky. Cumulus clouds are white and sometimes gray. They look like small, round puffs, similar to cotton balls, and usually occur during cold weather. Mid-level clouds. Altocumulus clouds appear to have one part darker than the other, so they look grayish-white. When seen on a humid morning, they often precede thunderstorms in the afternoon. Altostratus clouds cover the whole sky. They are grayish-blue and form before storms. The sun or moon can shine through them. If rain falls to the ground from an altostratus cloud, it is also called a Nimbostratus cloud. Low-altitude clouds. Stratus clouds are gray and look like fog. They cover all or mostly all of the sky. Some mist or light drizzle usually comes from them. Stratocumulus clouds are gray and lumpy. They are low in the sky. Sometimes they spread out and sometimes they line up in rows. Light rain or drizzle is associated with them. Nimbostratus clouds are dark, gray, and featureless. They are thick enough to block the light of the sun or moon. They usually produce persistent precipitation over a wide area. Clouds with vertical development. Cumulus clouds are puffy, white, and have flat bottoms. They are low in the sky and could predict good or bad weather, depending on their specific appearance. Cumulonimbus clouds have an anvil-like shape. They are linked to heavy thunderstorms, which is why they are also known as thunderstorm clouds. Frontal systems are due to the clash of warm and cold air masses. The boundary between the air masses is known as either a cold front or a warm front. There are three types of fronts. Warm fronts mark the boundary of an advancing warmer air mass. In North America, this is usually the tropical maritime air that originates from the subtropical Atlantic. Cold fronts mark the boundary of a cold air mass, and occluded fronts occur when the cold air mass associated with a cold front catches up with the warm front and the warm air is forced aloft. If you've looked at a weather forecast, you've probably seen a weather map that looks something like this. In red, we have a warm front, which is the transition area where a mass of warm air moves to replace a mass of cold air. In blue, a cold front. This is the transition area where a mass of cold air moves in to replace a mass of warm air. Here we have red and blue. That's a stationary front, and that happens when a cold front and a warm front meet up, but neither moves out of the way. And in purple, we have an occluded front, which occurs when a cold front, which moves faster than a warm front, catches up with it and forces it aloft. Humidity is the concentration of water vapor present in the air. Absolute humidity is the total mass of water vapor present in a given volume or mass of air. Absolute humidity in the atmosphere ranges from nearly 0 to roughly 30 grams per cubic meter when the air is saturated at 30 degrees Celsius, or 86 degrees Fahrenheit. It is the mass of the water vapor divided by the volume of the air and water vapor mixture, the net volume. Relative humidity is what we call humidity when talking about the weather. It's a measure of how readily water will evaporate from a surface, including our skin, to cool it. High relative humidity means that the amount of water vapor in the air is near its maximum for its temperature, so evaporation from surfaces is reduced. This can make a hot day hard to tolerate. Low relative humidity means that there is little water vapor in the air for its temperature, so evaporation from surfaces occurs readily. This can make the air uncomfortably dry, for instance, in an overheated indoor room during a winter day. Relative humidity is defined as the ratio of the partial pressure of water vapor in the mixture to the equilibrium vapor pressure of water over a flat surface of pure water at a given temperature. Relative humidity is normally expressed as a percentage. A higher percentage means that the air-water mixture is more humid. It is an important metric used in weather forecasts and reports, as it is an indicator of the likelihood of precipitation, dew, or fog. The dew point is the temperature to which air must be cooled to become saturated with water vapor. When cooled further, the airborne water vapor will condense to form liquid water, dew. When air cools to its dew point through contact with a surface that is colder than the air, water will condense on the surface. When the temperature is below the freezing point of water, the dew point is called the frost point, as frost is formed via deposition rather than condensation to form dew. The measurement of the dew point is related to humidity. A higher dew point means there is more moisture in the air. Precipitation, a form of water that falls to the Earth's surface. There's rain, snow, sleet, and hail. Rain is precipitation that falls to the surface of the earth as water droplets. Raindrops form around microscopic cloud condensation nuclei, such as a particle of dust or a molecule of pollution. Snow is precipitation that falls in the form of ice crystals. Hail is also ice, but hailstones are just collections of frozen water droplets. Snow has a complex structure. The ice crystals are formed individually in clouds, but when they fall, they stick together in clusters of snowflakes. Snowfall happens when many individual snowflakes fall from the clouds. Unlike a hailstorm, snowfall is usually calm. Hailstones are hard, while snowflakes are soft. Sleet, or ice pellets, is rain that falls from clouds but freezes before it reaches the ground. Hail forms in cold storm clouds. It forms when very cold water droplets freeze or turn solid as soon as they touch things like dust or dirt. The storm blows the hailstones into the upper part of the cloud. More frozen water droplets are added to the hailstone before it falls. Unlike sleet, which is liquid when it forms and freezes as it falls to earth, hail falls as a stone of solid ice. Hailstones are usually the size of small rocks, but they can get as large as 15 centimeters across and weigh more than a pound.